Imagine closing your eyes tonight, climbing into bed, and then realizing something terrifyingly simple. There is no bed, no mattress beneath you, no pillow supporting your head, no up or down. And if you fall asleep in the wrong place, there is nothing stopping you from drifting through the spacecraft. That sounds like science fiction, but for astronauts aboard the International Space Station, it is ordinary life. So how do you actually sleep when gravity is almost completely out of the equation? The answer is stranger than you might expect. Astronauts don't need to lie down to sleep. In microgravity, they can sleep in almost any orientation. They can be facing the ceiling, facing the floor, or positioned sideways. Their bodies simply float. But here's the first surprising part. Astronauts don't just close their eyes and drift wherever they want. They use sleeping bags that are attached to fixed structures inside the spacecraft. On the International Space Station, crew members typically have individual sleeping quarters or designated sleep stations, giving them privacy while preventing them from floating around the station during sleep. And those sleeping bags are not there because astronauts might fall out of bed. There is no bed to fall out of. The sleeping bag keeps the astronaut positioned safely and prevents accidental contact with equipment as they sleep. But now comes the part that sounds almost backwards. You might assume that sleeping in zero gravity would be incredibly comfortable because there is no pressure on your body. In some ways, it can be. Astronauts don't have to support their body against a mattress, and some have described simply floating inside the sleeping bag as a comfortable experience. But microgravity creates an entirely different set of problems. On Earth, gravity helps air move naturally. Warm air rises. In space, that doesn't happen in the same way. Inside the ISS, fans constantly move air around the station. This ventilation is essential because without enough airflow, the carbon dioxide an astronaut exhales can accumulate around their head. So yes, while you're sleeping in space, a fan is literally part of the life support system keeping you safe. And there is another problem. The International Space Station experiences roughly 16 sunrises and 16 sunsets in a 24-hour period because it orbits Earth about once every 90 minutes. Imagine trying to sleep while sunrise and sunset happen again and again throughout what your body is supposed to recognize as one day. Your brain did not evolve for that. Humans have an internal biological clock called the circadian rhythm. On Earth, daylight and darkness help synchronize that clock. In orbit, astronauts must rely heavily on carefully scheduled work, sleep, and lighting conditions to maintain a roughly 24-hour routine. And this is where sleeping in space becomes much more complicated than simply floating inside a sleeping bag. NASA research shows that sleep loss and circadian disruption are important concerns for astronauts because fatigue can affect concentration, decision-making, and performance. That matters enormously when you're operating a spacecraft hundreds of kilometers above Earth. One mistake in space can be far more serious than forgetting to set your alarm. So astronauts have structured schedules designed to give them enough time to sleep. They are generally scheduled for about 8 hours of sleep opportunity per day, although actually sleeping that long is another story. And here's a fascinating detail from NASA research. An analysis of more than 2,000 nights of sleep recorded during spaceflight found that astronauts averaged about 7.33 hours of sleep per night while in space, less than their pre-flight average of about 7.87 hours. So despite having a scheduled sleep period, astronauts don't necessarily get 8 hours of actual sleep. Why? Because the spacecraft is not exactly a quiet hotel. Fans run constantly. Pumps operate. Equipment vibrates. Lights can interfere with sleep. Work schedules can be demanding. And astronauts are living in a confined environment where emergencies can happen at any time. NASA specifically identifies noise, temperature, vibration, lighting, workload, and circadian disruption as factors that can interfere with sleep during spaceflight. Some astronauts use earplugs or eye coverings to make their sleep environment more comfortable. And then there's the psychological side. Imagine finishing your workday and knowing that outside your tiny sleeping compartment is an environment where there is no breathable atmosphere. You aren't sleeping in a normal bedroom. You're inside a spacecraft surrounded by equipment that is keeping you alive. Yet astronauts still have to make sleep feel as normal as possible. Some sleeping stations are designed to provide privacy, personal space, lighting controls, and a place where astronauts can retreat from the rest of the crew. And there's an important misconception worth correcting. Astronauts don't sleep because they're magically unaffected by space. Their bodies still need sleep. Their brains still follow biological rhythms. They can still become tired. They can still experience disrupted sleep. In fact, sleep has become such an important part of human spaceflight research that scientists continue studying how astronauts sleep before, during, and after missions. Researchers are even testing advanced lighting systems designed to imitate some characteristics of natural daylight and help astronauts maintain healthier circadian rhythms. But perhaps the strangest part isn't the sleeping bag. It's what happens to your body when gravity stops pulling your fluids downward. On Earth, gravity constantly pulls bodily fluids toward the lower parts of your body. In microgravity, fluids shift upward toward the chest and head. That's one reason astronauts can develop a characteristic puffy face and thinner-looking legs during spaceflight. So while an astronaut is floating peacefully inside a sleeping bag, their body is undergoing changes that simply don't happen during ordinary sleep on Earth. And here's another pattern interrupt. Astronauts don't actually experience zero gravity in the literal sense. The International Space Station is still firmly within Earth's gravitational field. Gravity at the station's altitude remains strong. The reason astronauts appear weightless is that both the spacecraft and everything inside it are continuously falling around Earth together. That condition is called microgravity. So when an astronaut floats inside a sleeping bag, they aren't escaping gravity. They're essentially falling around Earth without hitting the ground. Think about that the next time you see an astronaut casually floating past a camera. They're sleeping inside a vehicle that is traveling around Earth at roughly 28,000 kilometers per hour, while repeatedly falling toward Earth and missing it. And somehow, they have to get 8 hours of sleep. The technology supporting that sleep is becoming increasingly important as space agencies prepare for longer missions. A trip to the moon is one thing. A future journey to Mars could take many months each way, with crews living in an isolated spacecraft far from Earth. On those missions, sleep won't simply be about comfort. It could become a critical part of keeping astronauts healthy, alert, and capable of making complex decisions. So the next time you lie down on your mattress tonight, feel the weight of your body pressing into it. That pressure feels completely ordinary because you've experienced it your entire life. Astronauts don't have that sensation. Instead, they climb into a sleeping bag, secure themselves to the spacecraft, adjust the environment, block out light, listen to the constant machinery around them, and allow themselves to float. It sounds peaceful, but behind that peaceful image is an incredible amount of engineering, biology, and careful scheduling. Because in space, even something as simple as going to sleep becomes a scientific problem. And perhaps that's the strangest lesson of all. We spend our entire lives thinking that sleeping means lying down. Astronauts prove that lying down isn't actually necessary. What really matters is creating an environment where the human brain and body can safely enter sleep, even while you're floating hundreds of kilometers above Earth. If you enjoy discovering the hidden science behind everyday life in space, follow for more fascinating facts about the universe, because the next mystery may be even stranger. Now here's the question. If you could spend one night aboard the International Space Station, would you choose to sleep floating freely in microgravity, or would you want a sleeping setup that feels as much like your bed on Earth as possible?